think GE is starting small necessarily, but I think it's really important because like the point that this technology, you can't just throw it at every problem. You have to identify where it's going to be used. And GE is a company that has a process for doing that that's very well established and predates this latest technology. Maybe we start there, Colin, and just talk a little bit about how lean informs your AI initiatives.
Sure. One thing I do like, though, the last speaker talked about the fact that you start with a business case. However, when you start with a business case, that satisfies upper management. So if you want to get to middle management and to the actual people who do the work, what you got to start with is something that they know. It's part of their culture, which is how we got to lean. So GE has historically been a huge manufacturing operation. If you look at how we do things, it's not just manufacturing, it's services. So when you get to lean, what you're looking at really are two things. Yeah, I wouldn't go into the deep Japanese ideology behind it, but one is you're trying to find ways to reduce cost, right? That's obvious, right? And so we'll talk about that. It really starts with reducing waste, but then we get to cost. The second thing you have is something called continuous improvement. So one is Muda, reduce waste. The other one is Kaizen, continuous improvement. What that forces you to do is to develop a standard process. So for instance, services. And I use services because GE has like a backlog of $300 billion for servicing its assets, right? The aircrafts, the gas turbines, the steam turbines, the wind turbines. So if you look at services, what you'll find is that there's things you do pre-service. You collect all the maintenance information, you understand how the machine has been operating, then you actually bring the machine in and you do analysis. What's actually wrong? Then you do maintenance and you fix it. Then you have post-processing, all the documentation, certification, testing to get it back out. That is the process. In that process, there's waste. Waste could either be that you're looking at extra time. Somehow you're supposed to use 120 hours, using 160 hours. Or extra materials. You plan to use these 4 parts, using 6 parts. Or extra documentation because the test failed. So what we do is we look at that entire process and we say, give me both the things that are important, the cost, the time it took, but also give me the data. Now where this gets tricky is this runs across multiple organizations. Customer service at the start, the manufacturing guys had to produce materials, you had the services guys actually replacing stuff, and then the customer services in the end. But the great thing is once I look at that process, everybody knows it. There's a culture of trying to get that process better. So when I go in as a digital guy doing digital transformation and I say, can I get the data? Nobody argues, right? And then I take that data and that's where we apply the AI. I could do a simple thing. I could use computer vision to look at a blade to tell me about cracks. That'll help the person who is actually trying to analyze. Beforehand, I could use, NLP capabilities to actually look at all the documents I got together, and that document may suggest you have to replace 5 parts instead of 4, because the document is verbose. So all of these cases, I look for waste along, I introduce the AI and digital, that extracts the waste and actually adds value to the human beings doing their job. Doesn't replace the human beings at the start, adds value, and now the humans accept it. And so the idea was use lean, map out that process, get the data, stick the AI or digital transformation in that process, show in each case when you do something, either it's early warning or it's predicting a failure or it's optimizing, you extract value. So now both the upper management who see the money coming back and the cultural part, the middle and the lower management who see less time being wasted, they don't have to write documentation, it's all pulled in. So that combination of lean plus digital is where we start. And you could do it in small parts, and then you could expand it.
So give us an example of a project that you've shepherded recently that uses that process, that generated an outcome that was beneficial both to the middle management and to upper management.
OK, let's start on the analysis end. Simple visualization. For instance, if I think about, this is an old one, I'll give you 2. So the old one is a visualization. So to detect, you have these blades that spin, right? Everything in GE spins, right? Whether you're looking at a jet engine, it spins, it flies. Whether you're looking at a gas turbine, it spins, generates electricity, wind turbine spins. Cracks form on the blades. In the jet engines, what happens is that you literally have to go paint this thing on these blades, and then go into a dark room and take one of these scanners and scan this. Now imagine a person is doing that, 8 to 10 hours a day, 5 days a week, you find an interesting thing. You find out on Fridays, they miss more things. Mondays, they miss a few things. Middle of the week, they're good. So now, do we have a process that could actually use computer vision to look at that, extract that, and help them? Identify areas you want to look at, suggest things, right? That one gave us a significant productivity improvement. Because what you do if they have too many cracks, you throw that blade away. A set of blades easily, is something like $250,000, right? So that's one. The other part is, for instance, when you do things like analysis of the documentation before. So people you have to look at all the maintenance logs, you have to look at how the asset flew or how the asset ran if it's a gas turbine. And then they'll say, well, you know what, given that, I think we should, get 4 parts. Now the AI is saying, no, you should get 5 parts, and telling you, I think the way it was run, especially gas turbines, right? Gas turbines were meant to run all the time. But when you put wind technology, which is what everyone's doing in the energy transition, they now run a lot less, but they run in peaks. So this thing that was supposed to run this way is running like this. And so damage shows up in funny ways. So the average person who's been doing this 10 years says 4 parts. The AI says 5. When they go back and look at it, they say, you know what, it's right, it's 5. Now the trick is, the lead time to build one of those parts is roughly 16 months. So if you miss it, what's going to happen is that's going to show up. It's going to be there getting repaired. I can't finish the repair. That's a delay. Delays cost money. So that's 2 examples of the way we see it. And guess what? The humans like that. Because none of this works unless you get the culture bought in, where the humans are saying, you know what? This thing is helping me, not hurting me.
Yeah, it was a great point that you made in our first conversation about, you've got to convince even your engineers to accept this guidance, because it's going in, the AI is doing the analysis, and they're being told something that may be counterintuitive to them, and they think they know better, even though they're engineers, so they should be partial to these types of decisions. But you sort of have to massage it and almost explain the model to them so that they buy in. Can you talk a little bit about that?
Yeah, we have a technique we call humble AI. So the notion is, like any model you build is based upon the data that you gathered, right? So let me give you a wind turbine model. So in some cases, what we do, we look at a wind turbine and we either try to get an algorithm that could optimize how the turbine either tilts, so it can get the correct angle of the wind, and based upon that, it can generate more electricity. So say we take a lot of data and create this model, but the wind data we took, right, as you heard before, there's always bias in something. The wind data we took was operating between 4 meters per second speed and 7 meters per second. So we had a lot of data. The model was built for that. Now we actually put that wind turbine, because we built it for that wind turbine, but other people are installing wind turbines in different places, where they're going, for whatever reason, the wind suddenly gets to 8 or 9 meters per second. So what the actual humble AI does, it knows its zone of competency. It knows the data it's characterized on was built between 4 meters per second and 7 meters per second. So at that point, it says, well, I am not qualified to actually use this. And so it sends a signal that says, go back to the old algorithm that was written years ago. And then it asks for, can I get more data and be trained so I could deliver this capability now at 8 meters per second? So humble AI actually says, I know my zone of competency. When I'm not in it, somebody else should do something. Then I get more information and I learn. And that does 2 things. The first thing it does, it allows the chief engineer to say, you know what, my business risk is going to be confined when I bring on this algorithm. So that means I feel better. I've not exposed my entire setup. So therefore, it's easier for me to adopt it. The second thing it does is that it allows us to collect more data from them. Because the worst thing to try to collect from any operation person is more data to train a model. Because the view is, listen, right now, I am paid to deliver this value. Anytime I collect more data, it means I have to store that data. I've got to have different people doing different things. That's cost to me. My overall cost goes up. But now that person is seeing the value because they're making money on the algorithm. And then they're thinking, if I give a little bit more data, I'll make more money. So a lot of this is tied into the psychology of the people operating it, right? Because whenever you go into the GEs and the big companies of the world, unless you get buy-in at the cultural level, nothing happens.
Talk a little bit about how you think that generative AI may be able to help just some basic business processes. And I think we talked about RFPs and the amount of RFPs that are out there, the work that goes into them, and that this is going to open up whole new avenues for you.
Yeah, there are two dimensions. So one is the notion of productivity, and the other one is the notion of revenue, which is where we'll get to the RFPs. So in terms of productivities, so what tends to happen is that, for instance, you have a gas turbine. That thing lasts 30 years. So we have manuals. The manuals are written. Everybody has a copy of the manuals. But then what occurs is that as the world changed, we're now going into an energy transition. When these things were put in, they were put in because the gas turbines are the most efficient running way of generating electricity. So they ran all the time. Now, as we're moving to a mandate to have more renewables, you have more solar and wind. So what you have is this thing called a duck curve, which is when there's wind and solar, use that. That's the right thing. It's the cheapest source. And when there isn't, ramp up these large turbines. Now, they have never been built to run that way. So therefore, new failure modes are showing up whenever these things occur, right? So even though you had the manual and you had the experience, what's happening in different parts of the world, we see different problems showing up. So we write all of these cases. So you'll find a turbine that's in Denmark. In parts of the European Union, they're using a lot more renewables. So you look at Denmark, you look at parts of Sweden, lots of renewables. You look at parts in the US, if you look at maybe Florida, you do a lot more solar. So we write case studies about how turbines react in those places. So say someone sitting in the middle of the country, Iowa now, a good field service rep says, all right, something's happening here, and I don't know what to do. So I've read the manual. I've got to look at all these case studies. The cases we write could be as much as 80, 90 pages when you assemble everything else. They could be distributed over the course of the last 3 years. They could be as many as 300. How is she or he going to figure that out? So what we're doing with generative AI right now is we're taking these large language models, and no, we don't use the publicly available ones. That doesn't work for us. So there's a bunch of others. There's open source stuff you can get from Hugging Face. There's stuff from H2O. And when you bring them in, what you do is they're already trained, but you can tune them, and it's pointed at our data. And what it says, it will actually give our guys a summary or a Q&A, but it would also state, here are the cases, the 5 cases I use and ranked. Here's the manual I used. So once more, what happens there is that you're increasing the productivity. They would have taken, with this era, they may have taken 3-4 weeks to find everything. They would have had to call people. Some of those people in the field, they haven't called them back. Now, in a couple of hours, this thing shows up, and it actually has, I'm using this case, this case, this case, this manual. So now the confidence again shows up. Because again, if the people aren't confident and find a way to trace it, no, they may still call after. And they may say, what's happening? But you've begun now the process. Now, this has all been piloted, right? So we've got to spend time. And the focus is, can I increase productivity? Number one. Because I have top talent. That top talent is expensive. So can I increase productivity? And then as I do that, there are things I could automate. Second one is, again, the energy transition. Everyone is putting out these RFPs for 3 reasons. One is that government regulations now are saying you've got to have more renewables. States are mandating it. Second is you've got a whole bunch of cyber requirements that suddenly shown up. Third is you have customers that are saying, well, I have put myself, I have these 2030 targets, 2040 targets. So all of these things generate RFPs. These RFPs come to us. How many people do I have that could respond to the RFP? The first thing you want to do with generative AI is there are 2 different sections. One is the analysis. Given the RFP, how much of this I already have in place, right? Because a lot of the RFP is going to be about, I need these things delivered, I already have products, but I need to look at their terms and conditions for delivery. I need to look at their deployment schedules. Some of them have requirements that say it's this amount of it must come out, product and labor, out of the European Union. This amount must come out of the US. So if I can figure out if I have done this and I have 60% of it, now I can now use, again, a creative capability, like a large language model, to write that part of it. The other 50% now is going to be, all right, how do I actually address the fact that I have more inertia? How do I address the fact that I have weather conditions that are happening? So that will continue, that will use more human input. But even with the human input, can they look at other RFPs that have been written, pull that data, give it to the human so the human uses it better? So that's where we tend to focus on right now. But again, it's all about not only value, but risk. Can I codify the risk? Embedded in RFPs are things like, the liability I want has to be unbounded. Well, GE will never agree to that. I might do 1x, the amount you're investing with us, or 2x, but I've got to look for all these pitfalls. Then you get some RFPs that come, for instance, if you get one from the Saudi government, this thing is 700 pages. Right? So, wow, whole different thing there. And in parts of it, there's unbounded responsibility. There's parts that says the data can't leave. The parts that talk about the type of security. Some of it not doable. So you've got to push back. And it requires deep legal capability. We don't have that many lawyers that can do that. So all of it is a human working with the AI, understanding the business context.
So we've got a couple of minutes left. Let's talk about how you see the future of product development in partnership with AI and AI actually developing entirely new things.
Yeah, I think there are two ways to think about that. One is products and one is operations, right? Because, we build assets that last, many years. So I can build an asset, but also I got to operate it. So in terms of products, so I think one of the speakers talked about the fact that it's great at brainstorming, right? We have begun using it. Again, generative AI has been around a while, and we have created these simulators or surrogates. Now with generative, it's a little bit easier to create these things. And what you find is that what we're doing is we're focused on an area. I don't ask it to do an entirely new design. I start off by saying, I need to focus on the same design I have, but find a way for me to deliver it with lower cost. Or I have 3 new materials. Because the materials drop the weight of it or increase the structural integrity, design with these 3 materials instead. So we slowly introduce it into it. Then after you do 4 or 5 dimensions, whether it be cost, whether it be material strength, whether it be how fast you could deploy it, right? Because sometimes, to build one of these power plants is 5 years. Can I do it in 2 years? Especially important with small, modular reactors. Then you actually say, I want to combine all 3. And again, it's just brainstorming, because the problem is most of the top talent we have done it one way for a long time, right? And so they have these design rules fixed in their head because they know how things go. The young people we have coming in want to be adventurous. Well, let them be adventurous, right? And so we combine them with the older people with ChatGPT, and now what comes out of it is interesting. It'll give you 10 different potential things, only 2 may make sense. Right? And the older guy will say, you know what, these 2 are brilliant, but we just can't manufacture that. That's one. The second thing is the process. So I go back to energy. So we now have systems in which we've added renewable capabilities, which means it's the fuel in renewable is the weather. Can't predict the weather. So you have something that's insane to manage. Before, we had energy being generated with one large, big power plant, send it through transmission, distribution, and consumed. Now people on the consumption side are putting up their own solar, so that it's a 2-way flow of energy. So the grid is one of the most complex things in the world we're looking at. Added to the fact, if you look at what the US, these are the civil engineers, Society for Civil Engineers said, by 2025, 45 to 50% of the people who have greater than 20-year experience will retire. So we're walking into something, and energy is fundamental, right? Here's the funny thing about energy. When we walk in a room and turn on the light, nobody claps. But this is the foundation of our society. And so now you're going to change that at the same time, with something that's the foundation. So now how do the operators react? You have operators that have to react to changing wind conditions, changing cyber conditions, a new set of regulations. They cannot. So we're building more autonomy in the grid, where the operator itself, will be only there for situations that are extreme. But with GE, So we learned interesting things, for instance, in aviation with our jet engines. The plane can fly itself and land itself. You have the pilot there when there's a bad situation. However, 80% of the time there's not a bad situation, so the pilot sits there comfortable. And that pilot is not prepared for when there's a bad situation, because 80% of their time is spent reading a book and relaxing. So the same thing when you run these grids. We're going to get it to the point where it's so autonomous that when you have a problem, how the hell do you do this? And so now we're using generative AI to create scenarios by which we train the people who are in these rooms on extreme things. So rather than sit there reading a book, we'll run through a few simulations like you do in some of these nice gaming systems that our kids play, and see how they react and train them in extreme situations. It's not just a cyber attack. It happens when you're actually doing an upgrade for security patch and you get another attack by a security assailant. At the same time, it happens to be a hurricane coming in. How do you deal with all of that in once? So we're developing new processes, new products.
Excellent. Colin, always a pleasure to talk to you. Thanks so much for coming.
Same here, Dan.